brick ledge, we're going to put in some brick ledge. Our brick ledge panel, Jerry, hold up here. That's our brick ledge panel. That same panel, depending on where we put the groove, could be either a 4-inch ledge, or if you flip it upside down, it could be a 6-inch ledge for stone application. This is just one ledge detail for creating a ledge, but the most common for somebody that's utilizing brick on a home. That brick ledge panel from top to bottom is 2 foot tall. So if I have an 8-foot wall, what would actually be sent to you on site you'd be 2 foot short. So you'd have 6 foot worth of panel for one side of the wall, and then plus your 2 foot brick ledge panel gets you your 8 feet. So what happens is you need a chunk underneath and you need a chunk above, depending on whatever height that brick ledge is going to be set at. A lot of brick ledges step all over the place. We're at certain heights for backfill. We rarely know what that height can be. So we just send you the panels that you're going to need to make up the height of the wall, and then on site you will cut what goes beneath and then put the remainder on top.
Here's how I lay it out. I'll just put my 4-foot panels up, anywhere on the brick ledge. And just mark it, slide them panels back out, and cut it to height.
And as you can see, you could step that brick ledge every 8 inches if you needed to.
Yeah, just change it.
So you could step it in the wall for your grade change.
So you could use that for, like I was talking about the application earlier, setting trusses or floor trusses, or is that something?
We don't see it too often for setting floor trusses on, just because then it gives you that funky angle detail to deal with inside the house.
Yes.
Underneath the truss, but if it is like a top bearing truss that you could then hide that angle within the truss, we have seen that before, yeah.
Right.
What kind of rebar detail do you have coming out of the brickwork?
That
How are you putting your stirrups and
that particular panel is, we have it engineered without rebar in, it'll hold a story and a half of brick. So if we're going beyond that, then what we'll do is, of course, we could drop a horizontal in there, but then you're going to want to see your rebar tying back into the wall. And then there are, I don't know if there's any, is there a detail on that, Nancy? Yeah.
Because it changes.
Yeah, it changes based on how much, what are we putting on that brick or stone or whatever, but we can certainly help out with those details. A lot of times if it starts to get in, in the commercial world, we'll see it more so spec'd out by an engineer for us of what we need to do, but definitely just like you would imagine a rebar that has been into the wall itself and connected to the vertical rebar is what we want to see, so it can't pull away from the wall with larger loads than that story and a half. And that'll be a real good question for Engineer Ben. And Ben will be here right after lunch. So the brick ledge, we're just kind of keeping it at the same height. So you can see again, we put the panel underneath, put the 2-foot brick ledge panel in, and then the panel above. Now we'll show how we. Oh, we can. Now we'll show you how we brace it.
Want to talk about how easy it is to take it apart? Or if you make a mistake, how easy it is to take it apart?
Yeah, it's real easy to take the forms apart if you do need to change something up, of course. Peel them apart. The further along you get, the more bracing you have up and the seat metal on top. The further you get along closing it in, the more difficult it gets, of course. But so we will throw a brace across the top. Mainly what that brace is doing is going to hold those panels from falling down into the brick ledge area. So we'll put a 2x4 up there. You can see it in the bracing detail for the brick ledge on 25, page 25, 26, I believe. There's a 2x4 that goes right above the brick ledge, and then we run a plumber strap, just a perforated strapping from that 2x4 down to the stud underneath the brick ledge. And that helps protect for the weight of concrete out there on that ledge from damaging the panel at all. We space that strapping. If it's a 4-inch ledge, you get away with every 3 foot or so with a strap. And after the brick ledge spot, we'll hit,
Barry, hold on to back.
and there are, I think we have some loose leaf ledge details in the folder as well that aren't in the manual. There's just some sheets in there. So there's all different kinds of ledges that we can create. And there's more beyond what you see in those details because we can get into some pretty crazy ledge situations. And the form is so easily manipulated to do different things, put block outs in, do those paper tops, if I have ICF below grade and ICF above grade, and I want to create a ledge, we can use a 6-inch or a 4-inch wall form and then jump to an 8-inch, just use a 4-inch just for behind the floor system. There's all kinds of different things we can do to create ledges. You could put a board inside the wall, slide it in, and remove it afterwards to create, an 1.5-inch ledge for a floor to sit on, like a traditional method. And you'd be forced to then cut through our stud, of course, to remove that section. But a cordless circular saw will buzz right down our wall to snap a line on it. You could make 2 cuts and pull out a section of wall. And we're also going to show, if you didn't have brick ledge panels or didn't want to utilize the brick ledge panels, you could simply use a 2x12 as well, which is that top detail you see on the screen. Basically creating the same thing just with lumber. Some guys actually prefer that method. But it does give you a spot in the wall, of course, then that's not as insulated as the rest. So individuals that are very energy conscious, and that's why they're using our forms, will tend to use our brick ledge panel, because then you still have all that insulation there. Brick ties, very common question for us. How do I attach my brick to this wall system? Because I don't have a direct concrete application. You can screw a regular, in most residential applications, of course, or even some lighter commercial, you can just screw a regular brick tie right to our stud with a screw. That stud gives you about I believe it's about a 290 pound per screw pull out. So if you need a certain pull-out application, or if we have to have a much stronger connection for some reason, there are connectors in the ICF world that allow for a plate to be actually poured right into the concrete, you just cut a slit right in our panel, shove this in, it gets poured in the concrete, and then I can adjust my tie up or down with the slot where I need to be in my brick or stuff, or block. And there's other tie options as well. Those are some of the most common. I could, of course, tap con a tie right to the concrete if I need a real strong attachment as well. Just use a longer tie, of course, because I have 2.5 inches of polystyrene there typically.
What if you needed to bolt a lintel on it, the customer decided after I had
If you need to bolt the lintel on, then you're most likely looking to go direct to the concrete, and so you need a little bit longer leg on your angle iron.
You have to cut the foam out behind the lintel.
So explain to me what you would be trying to do.
If you were bolting a lintel iron on the face of the wall, if the
Yep.
customer decided after to have direct,
Yep.
would you have to remove the insulation where that lintel connects to the crete?
Yeah, you would most likely want to remove that in that section to get to a good concrete connection. Now, of course, you could remove the foam, directly connect your angle on there, and then put foam back in place over, because your brick's going to be 2.5 inches away from that concrete, right? Or 3 inches, or whatever your airspace you need as well. So you can still get some foam behind there over that angle to put it back in place, but you would need a longer leg. 2.5 inches. Yep.
You guys have anything with like slot leg? Or what, they're looking for slot legs?
That's where we would probably just put in a block out and then remove the foam to get that ledge. So you got your typical 1.5 inch, in that scenario. Otherwise, what some guys will do that use our forms is purchase our brick ledge panels there and put 2 panels just like you see on that wall there, about every 4 foot on center. So you're not putting them the whole way, you're just putting some every so often to hold up a ledge, or we'll use those on a porch too, to hold up a porch slab on the wall. Yeah, sometimes that block out is nice in a garage because it's not necessarily horrible to remove that in a garage so you don't see it too. When you put a board in there and then cut the studs and the foam out, you can kind of remove that so your garage slab will look tight against your wall as well. And it just looks better. Otherwise you see that when you're looking down in the garage, that top of that foam. And quite honestly, in a garage, like for the remainder of the garage walls, the 4 foot frost walls, most of the time that's a regular poured wall and not our system as well. Some guys will use our system in the frost wall situation, but of course, you're not getting the full benefit of, so you're paying for the polystyrene that's getting buried on both sides. You're not getting as full benefit, but some guys will just be half to put in that scenario. So there's the 2x12 method. If for some reason you needed a brick ledge and didn't have the brick ledge panel, gets braced really the same way. Now we'll go through a window. Openings in the walls. We do a lot of above grade wall. I would say about 70% of our business is in the above grade structures, just because A lot of commercial buildings are all above grade, and it takes up so much more wall than residential. But we still also do just foundations. We do just crawl spaces. We do addition, frost walls, anything from very small jobs all the way up to very large jobs. We have the largest residential home in the country all out of our form system. That's about 110,000 square foot home. So anything from very small to extremely large. And then in the commercial realm, same thing. We have yet to run into a project that we could not make our forms conform to, whether it be radius walls, odd angles,